Okay, good morning, class. You're on to Mamu with Jarvis, and this is a mathematics experience for grade 7 class. We'll be looking at the matter of geometry because this realm is concerned with geometry. And in some of the videos I've done, I've tried to talk about what to expect in geometry. So for a grade 7 class, just leaving primary school into secondary school, what will be the expectations from you? And as such, we're starting with a very simple topic today that borders around angles. Angles in the matter of what? Measurements. I've done very extensive videos on the matter of geometry as it pertains to lines, angle, and points. But I'll try to keep the narratives very simple in introducing this matter so that we can actually flow as this course would progress. So I have a model I use when I talk about geometry. Geometry is built on a simple idea I call my PLA model. P for points, L for line, A for angle. Point, line, and angle. I wouldn't go in depth to explain it because I have a video I've done extensive work on. So I would attach the link after now, and I'll advise you to go to my playlist, check grade 10, formal geometry, points, lines, angles, and I think that will take care of that. So sticking to what we have to do today, what is an angle? An angle is formed when two lines, they intersect or they meet. They intersect or they meet. So if two lines intersect or they meet, we have at least an angle being formed. So if they meet, we're going to have at least two angles. And if they intersect, we'll be having in the neighborhood of what? W, X, Y, Z. We have a neighborhood of about 4 angles. So each of these letters indicated in the space are called what? Angles. So an angle tells us how lines or arms, as it's called, are being extended. If you see your your compass or your dividers, if you open it up, what happens is that what? As you're opening it up, the space you're seeing is what we call the angle. Maybe I should get my compass rather. I have a math set here, so I'll just quickly open that and make our work a bit practical. All right, so this is a line, this is another line. If I open this line, the separation between the line is what we call an angle. So we call it an angular separation or displacement. So this is what we call the angle. You discover that in this setup, the lines meet at a point. So what you're going to have is an angle on top and an angle beneath. So that tells us what we need to know about an angle. So to explain angle at your level, we imagine a wall clock, an analog wall clock. So I'm going to try to draw that on the board. You have seen a clock before. So we'll talk about angle as what? Rotation. Angles as what? Rotation. We have a circle on the board. I want to draw a clock. This is a traditional clock we know. So we put a point at the center, and then we try to label them out. So remember we start that this will be 0, this will be 12, sorry, this will be 12, this will be 6. You remember your primary school very well. And maybe I should make it a little bolder. This will be 12, this will be 6, this will be 3, and this will be 9. Then from there, you separate, this will be like 1, this will be like 2, so I'll write 1, I'll write 2, I'll write 4, and I'll write 5. Then I'll write 7, and I'll write 8. I'll write 10, and I'll have what? 11. So This is a clock, and this is how we draw the clock. Now, remember that if you remember your clock very well, a clock has two arms. We have what is called the minute arm and the hour hand. Okay, let's use hands. That will appeal to us better. We have the minute hand and the hour hand. You discover that what you have one that is small. Let's start with a very simple time. This is the hour hand. And this is what we call the minute hand. You discover that as this one is turning, this one will be moving a certain level, moving gradually. When this one completes one full movement, if it starts from here and goes round, it would have covered 360 degrees. 360 what? Degrees. So if it goes from here and goes round like this, it would have covered 360 degrees. And when it covers 360 degrees, it would have moved 1 hour hand. It would have moved what? 1 hour distance, if you choose to call it that. If it moves from here to be 4 o'clock, it goes again, it will come to 5 o'clock. It goes again to go to what? 6 o'clock. So as it keeps going round like that, it will be making what? It will be making what? 1 hour movement. So this minute hand, let me call it minutes. When it goes round, we know that 60 minutes make what? 1 hour. So when it covers 60 minutes, it will make 1 hour movement here. So this is what is called the hour hand. So when the minute hand goes 360, it will make 1 hour hand movement. Is that clear? So you discover that those who design the clock, they design it such that if this minute hand moves to 3, it would have moved a certain distance from here. If it moves to 6, it would have been halfway here. If it moves to 9, it would have gone to 3/4 here. If it goes back to 12, it would have completed that distance. So you discover that this is what we have. As it keeps rotating, moving around, as it keeps moving around, the hour hand begins to move. So to further explain this, we're going to go back to our primary school and look at certain types of, we're going to look at certain times in our primary school. So I'm going to test to see whether you remember this. I'm going to draw 4 clocks on the board, and you're going to try to tell me their times. I'm doing the recording on purpose so that for those of us who might not be used to the drawing is an important aspect of geometry. You must be willing to draw. And please, for the purpose of this class, I would expect you to use your pencil. I usually don't like the idea of students using biro to draw. It's very, very, say, unprofessional to do that. Use your pencil to draw. So if you don't have a pencil, grab one and let's draw. So this is between this space I have that, so I'll have 1, I will have 2 here. Between 3 to 6, I will have 4, I will have 5, I will have what? 7, 8, 10, 11. You just mentally try to place the spacing. I'm going to draw all of them, so don't think maybe it's on purpose, because I need you to be able to draw this. Are you seeing that? Now I'm going to draw the last one. So I'm going to put 4 different times for you, and I'll see if you can. It's like there's one I've not finished labeling, all right? All right, so I'm going to start by naming this one. This is the long hand, and this is the short hand. What time is this? I'm going to do another one. This is another one. I'm going to do another one yet. The long hand. Just before 2 o'clock. And then I'm going to do another one. The long hand here. Short hand. So these are 4 times I want you to look at, and I want you to write the time given to you on the board. All right, so I'll give you some time to do that. Okay, so this is what? The long hand, minute hand is at 6, and the hour hand is between 3 and 4. So this will be what? Sorry, the minute hand is at 6. The hour hand is between what? 3 and 4. The hour hand is always the shorter hand. Sorry for that mix-up. Now, so this will be what? Half past 3. Half past 3. Meaning the minute hand has gone to what? 6. This is the position for half. Good. Now, what is this one? You discover that the minute hand is at 12. Anytime the minute hand is at 12, it means that there's a complete hour time. So this will be half past 3 o'clock. And let's look at this. This will be what? 8 o'clock. So that will be 8 o'clock. Sometimes we have this apostrophe on it. Now, the minute hand here is at 9, and the hour hand is almost close to 2. So we'll say that this is what? Quarter to. The 9 position suggests to. When you cross this position, you're going to. Within this position, it is what? Past. Quarter to 2 o'clock. Now, what about this one? This is at 3. Anything here is called past. Anything here is called to. So this will be at 3, it is quarter. So it will be what? Quarter past 12 o'clock. So these are these 4 times are very, very important for you to take note of. When it's at this position, it is half past. This position is a full-time description, 8 o'clock. So once the minute hand is at 12, any other description will be, whether it's 1 o'clock, 2 o'clock, 3 o'clock, 4 o'clock, 5, as the case may be. When it is at 9, the minute hand is at 9, what I would suggest is close to the next time. So if it's here, and you notice that the hour hand will be close to 2. So if I'm going to draw this line to be close, I could have close to 3, close to 4. So it is quarter to, approaching. When your minute hand is here, it is leaving, so it will be past. It's leaving, so it will be past. So this is quarter past 12. And you notice that the hour hand will be somewhere like 1/4 of just leaving 12. Now, with all of this description, we are ready for the next work we are going to do. Now, let's go back to our clock. If we start from here and we move round this clock, the minute hand moves round the clock. What the minute hand has succeeded in doing is to complete what is called 1 revolution. So 1 revolution will be equal to 360 degrees. and the revolution is completed by the minute hand. So when the minute hand moves round, it has completed what? One revolution. And that is what? 360 degrees. So we can write this for short. So let's assume the time was at 12 o'clock. And then the time is now at 3 o'clock. How many revolutions has been covered? If the time was previously at 12 o'clock, and then it is now at 3 o'clock, how many revolutions has been covered? I don't know what 12 o'clock would look like. That's 12 o'clock. And then it moves from 12 o'clock and it becomes 3 o'clock. How many revolutions have been covered? Let's send our comments to the chat. 3 revolutions, beautiful, would imply that you're going to multiply 3 by 3,000. Beautiful, which should be a carry of 1. 3 times 3 will be 9 plus 1, 10. So that's 1,080. 1,080. All right. So that settles that. So one revolution is what? 360 in degrees. 2 revolutions will simply be what? Times 2. And that will give you what? 720. 3 revolutions will simply be what? 10 revolutions will simply be what? Half revolution will simply be what? Divided by 2. Means divided by 2. And if you do that correctly, that will be 180 degrees. 1/3 will simply be what? Divide this by 3. 1/3. Divide that by 3. And that will be what? 120. 90 is what? 90 will simply be what? 1 revolution. 90 degrees is less than a revolution. So it will simply be what? 90 divided by 360. And if you do that correctly, that will be 1/4. 1/10 of a revolution will simply be what? 210 will be what? 210 is less than 1 revolution. So you divide it by what? 360. So you cancel. 3 going into 21 will give you 7. 3 going into 36 will give you what? 12. Half of a revolution in degree will simply be what? 360 divided by 12. And that will give you 30. So the answer becomes what? 30 degrees. So that's just an idea on how you convert revolutions to degree or degree to what? Revolution. I usually tell my students this. One of the fastest ways to improve when it comes to this matter is after the class, write the questions again and see if you can. Thank God you have the video recording. Play to where the questions have been written. Write it again and see whether you can solve it exactly the way the teacher has solved it. If you can do that, then it shows that you've understood the topic. I'll give you some time to process this and then we'll go to the next phase of our work. Angles between hour and minute hands. The angles between the hour and the minute hand. So I'll start by drawing my clock. Bear in mind that you'll be drawing a lot here. Now, right. This is a long hand. And this is the short hand. Now, this is the hour hand, which we've established, the minute hand rather. And this is the hour hand. So this is what is called 3 o'clock. We know that the distance around the clock is what? 360 degrees. So, but now we are concerned with what is the hour, the relation between the minute and the hour hand. In degrees. In what? In degrees. So that's very simple for us to do. Very, very simple for us to do. Now, at 3 o'clock, we know that the minute hand will be at 12 and the hour hand will be at 3. Is that not? So, what then is this distance or the angular distance between each of these angles here? Now, we're going to do something interesting now. We know that the angle in the angles or the angle in degrees of one revolution is what? 360 degrees. Is that not? 360 degrees. That's for a revolution. Now, so there are 12 divisions in a clock. There are 12 divisions in a clock. I say it 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So if there are 12 divisions in a clock, it will mean that one division. Now, what do we mean by one division? Because I've counted it like this. Some students might get a little confused. Division is the space. So let me call it again. Look at this. 1, 2. So when I move from one step to the next, it's a division. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So that's the 12 divisions I'm talking about. It means that one division will be what? 360 degrees. The angle we move round divided by 12 number of divisions possible in a clock, which is what? 12. And that will simply give me 30 degrees. How do I do that? If I cancel this out, I can use 2 to cancel, I'll get 6. Or use 2 to cancel, I'll get 180. Use 2 to cancel, I have 4. I have 3 rather. Use 2 to cancel, I have 90. Use 3 to cancel, I have what? 30. So this is 30 degrees, which means that one division will be what? 30 degrees. Now I come to my clock. I'm asked, what is the angle in degrees between what? In what? At what? 3 o'clock. The long hand, which is the minute hand, is at 12. The hour hand is at 3. So I count the number of divisions I can see. I have 1, I have 2, I have 3. There are what? 3 divisions. So it means that at 3 o'clock, there are 3 divisions. There are what? 3 divisions, which would imply that the angle between the hour and minute hands at 3 o'clock will be what? 3 times 30. Because for every 1 o'clock, you have what? 30. So that will be what? 90 degrees. That will be what? 90 degrees. So that will be what? 90 degrees. So I'll stop at this point because I want to ensure that you follow up the ideas. Now, there's a question given here. They said you find the smaller angle. I won't explain that, and I'm doing that intentionally. I'll do that in my next class. So, as way of assignment for you, I want you to go back to exercise 8A and look at question number 2. It's on page 57 of your text, exercise 8A, that's the new general mathematics for JS1, 8A, and then just do question 2 for me. Notice that I have focused on when it is a full-time measure, 1 o'clock, 2 o'clock, 3 o'clock. I'll also try to teach you when it's quarter past, half past, quarter to. There's a way you handle those ones too, right? So with that settled, I also want to give you something else to do. If you go to page, where is that now? If you go to page 63 of your textbook, revision test 8. Revision test 8. I also want you to do question 1 and question 2. Revision test 8 on page 63 of our textbook. Do question 1 and question 2. So those are the assignments. If you missed the description, when you watch the video again, you'll be able to tell the exact questions I've asked you. So I hope you have a wonderful time. Make sure you go back and do this work and rewatch the video. And I'm trusting you're going to have a better understanding if you do so.